Hello, my name is Lenny Vermoss, and my contact information I'll provide a little bit later in the video, but I have an intriguing geometry problem for you to think about today. What I would like you to be able to create is a solid object that will go through and plug each of these holes, a square hole, a triangle hole, and a circle hole. Now, when I first present this problem to students, I give them a piece of cardboard to kind of work and some clay to kind of model it. And this is usually the object that students first come up with. And you can see it's kind of a multi-tool type of thing. So it has a square on one end, so to square, plug it, has a circle and a triangle. And it does plug each of the holes, but the problem is that it doesn't go through each of those. So, and they'll come up with some other unique characteristics and shapes for that will work. At first thought, this might seem like a pretty impossible problem, but one ray of hope comes from three-dimensional objects. So if you think of three-dimensional objects, usually we think of length, width, and height. But if an object has three dimensions, it seems possible that it would be able to have three shapes that you could use. Another way that you can look at this problem is to create a shape that would cast three shadows. So when you hold it one way, it casts a circle shadow. When you hold it another way, it casts a triangle shadow. And when you hold it another way, it casts a square shadow. So what I would like you to do is to think of a common shape that would work. And many times the common shape that students first come up or think of is a cube. A cube will work and plug this hole and go through it. But unfortunately, it doesn't work in this hole or this hole. All right? Another object that you might think of is a cylinder, right? A cylinder will go through this hole and plug it, but it doesn't go here or it doesn't go here. Well, my question and a strategy you want to do is how can I modify this cylinder so that it might fit in two holes? And I think you can see that if I made this cylinder a little shorter, like this, it would go through, it's going to go through and plug the circle hole. It's going to plug the square hole, but it won't go through the triangle hole. So it fits two, but not the other one. So at this point, I usually pause and give you a chance to give the students a chance to kind of work on some other shapes. When the students think about it, one shape that they come up with is a triangular prism. Right? So this triangular prism will go through and plug the triangle hole, and it will go through and it will plug the square hole. All right? But it doesn't do the circle hole. So it does two of them, but not the other one. A cone is a unique shape, and a cone will go through and plug the circle hole, and it goes through and plugs the triangle hole, but it doesn't plug the square hole. So again, it does two, but not the other one. A pyramid is a shape. A pyramid will go through and plug the triangle hole, and it will also go through and plug the square hole, but it doesn't do the circle hole. So I've got several shapes that will do two, but I still don't have one that does three. At this point, you want to step back and kind of think, how could I change one of these shapes so that it would actually fit through all three? And this is a shape, I'll kind of give you a hint, that you want to think about modifying. Right? So here's a solution. This is a solution that was created by a student, and I'd like to give Tom Price some credit. Tom was a colleague of mine at Norris long time ago, and I think he kind of started this problem, and I created and used it. But he had a student that created this, and you can notice that what it looks like is it has a circle on this side, it has a square on this side, and on this side here it has a triangle. And the object, if I take this, I take my cylinder and I cut it, notice what I have is a circle on this end, a triangle on this side, and a square on this side, so that it works. So it goes through this side, plugs it, goes through this side, plugs it, and it goes through this side and plugs it. Here are just a few final thoughts about the activity. First of all, I wanted to encourage, as you work with your students, that they have a growth mindset with this, that they learn from their mistakes, that they're persistent, patient. And I think one of the overriding things is if you approach it as it's a three-dimensional object, that it seems possible, although not very easy, that there could be a shape that would be able to fit through all three of the holes. Often get what's the name of the shape. You know, you have pyramids, cylinders, all the shapes. I don't know that the final shape has a specific general term that you could call it. I also want to make sure that I thank Tom Price. Tom, again, was the one that first introduced me to this problem. And I've enjoyed sharing it with students over the years. The final thing relates to the shapes, and if you look at the shape in the middle, when I first created this, I ran into some problems because I wanted to make that an equilateral triangle, but because it has to fit inside of the square, it's actually an isosceles triangle. The length across the bottom is the same as the length of the square, and so it's not an equilateral triangle, but an isosceles triangle. I hope you're able to enjoy challenging your students and sharing with your students and making math fun. So thank you very much.